This is the third and final video for force. This is on free body diagrams. We've already taken a look at a few of them, but I'm just going to go over how free body diagrams work for each of the 5 forces we are using for this unit. So we'll start with gravity. Gravity is simple because it always points downwards. There's no exceptions to this. Gravity is always pointing towards the center of the planet, so gravity points downwards. Next one, normal force. The word normal in mathematics means perpendicular to. So if two lines are normal to one another, that's another way of saying they're perpendicular to each other. So what exactly is perpendicular? The force, the normal force, is perpendicular to the surface. So for example, here on the left we have a box on the ground. Normal force for the box on the ground is perpendicular to the surface. It's up. Now if we look at the next one, if we have the surface, if we impose it onto this dot running like so in red, the normal force is going to be 90 degrees to that. Normal force is always perpendicular 90 degrees to the surface. Next force is friction. Friction is always perpendicular to the normal force. Therefore, it's always parallel to the surface. And it's always in the opposite direction of the motion, or the attempted motion in the case of static friction. So let's say we have our 2 blocks again like we did in the last screen. This block here at the bottom is being pulled to the right. Therefore, friction is going to oppose it, and friction will be to the left. If we look at the next one, this box is sliding down the ramp due to gravity. That means friction opposing this is going to be directed up the ramp. Next one is tension and springs. Tension and springs, they always act along the rope or spring. So in our first picture down here at the left, we have a person pulling a block to the right. Therefore, the tension is going to be directed to the right. In the second one, we have a pulley system with 2 blocks on it. The block on the left, the tension will be directed upwards along the rope, and the block on the right, the tension will once again be directed upwards along the rope. In this case for tension, the forces are still directed along the rope, so we have one that's up and to the right, and we have another one that's up and to the left, but a little more left than up, unlike the first force I drew. Last one, spring. Spring will be directed up along the spring. Now let's do multiple forces. Let's go ahead and take a look at this one on the lower left. We'll say there is gravity and normal on this. So we have gravity down. You have to apologize for the lettering. It's not going to be very pretty. There's mg. And then normal. On this block here, on the right, let's say it's sliding down, or would be sliding down, so there is gravity acting down. There is normal. Normal is going to be directed up and to the right. And then there is friction, which will be opposing the attempted motion of the block sliding down the ramp. In this case, we have a box suspended by 2 ropes. Gravity is always in play. So here's mg. We have 2 tensions. We call this one tension 1. And then the other rope creates tension 2. This one with a spring. Gravity is present, as always. And then we have the spring force directed upwards. Force, spring. And this one here, a little more complicated. We have someone who's actually pulling the block up the ramp. So let's stick with what we know for sure. There's going to be gravity down. There are two solid surfaces in contact, so there will be a normal force. Again, it's going to be directed up and to the right. Tension is along the rope, so tension is this way. Now friction's a little tricky. Last time friction was directed up and to the left. It will not this time, since the block is physically moving up and to the left. Friction opposes that direction of motion, so friction is down and to the right. Thank you for watching.